All right, everyone. Well, welcome again to one of Pacific Science Center's very own virtual planetarium shows. This is going to be our third show we have done so far. So far we have covered the constellations. Last week we covered the planets of the solar system. And this week we are going to cover some of the kind of wacky moons you may or may not have heard of, may or may not be familiar with. But kind of to help us out here today, my name is Max. And then controlling the planetarium, we also have Marissa.
Hello, everybody. So yes, as Max said, we are going to be exploring the moons of the solar system. So let me share my screen here with y'all. There we go. Everyone should be able to see planet Earth right in front of us. Now I am going to turn us away from planet Earth because we are going to start out with our own moon. Let's fly there. And as we're heading to our moon, go ahead, Max.
Now, if this is your first time joining us for a virtual planetarium show, we are going to try and cover as much as we know about each of these moons. But if you do have any questions for us or any comments for us, feel free to type those into the chat box on the live stream of YouTube, and we will try to get to them the best that we can.
Yes, that's right. We are trying to keep this show about 40 minutes this time. We went a little bit over our past two shows. Too much exciting stuff to talk about. So we'll do our best to get to as many questions as we can. If we don't get to yours during the show, feel free to add it as a comment under the video, and we'll try to make sure those get answered later on afterwards. All right, here we are at our own moon right here. Let's flip us around. This should be familiar to most folks. Hey, Max, what are your favorite things to say about our moon?
Well, I always like to kind of point out that Earth just has one moon. So people were pretty unique in naming it. They simply called it the moon, since it was the only one we were able to see kind of orbiting around Earth. Something I like to point out, Marissa, and you can kind of see it there, is this, as you mentioned, is kind of the side we might be familiar with. So it's the side always facing Earth. Now, that is where a lot or all of the Apollo astronauts that landed on the surface of the moon landed on, was the near side. It's much smoother than the other side, the far side, which is a lot kind of bumpier, a lot rockier.
That's right. I'm flipping us around so we can see the far side right now. So our moon is tidally locked. It's sort of a fancy way of saying the same side faces us all the time. So this is the side that we're all familiar with. This other side is one that we haven't seen. We can't see from planet Earth. A lot of folks call that the dark side of the moon. Turns out it's not actually dark over there. The sun shines on it. But we just can't see it over there. Something else I like to point out is, I'm flipping us back around to our side, the near side of the moon. All these big dark spots here. A lot of folks think those make pictures of like a man in the moon or a bunny rabbit. These dark spots are only on the near side, and scientists aren't completely sure why. There's a few ideas. If we think back to, if I talk about how the moon was made, we believe the moon was made from an impact event. So something really, really big in the early days of the Earth smashed into it, and the bits and pieces and debris left over from that formed our moon. And back then, the Earth was really, really hot back in its early days, really, really hot. So there's this idea, this hypothesis, this theory that since this side of the moon was facing that really, really, really hot planet Earth, the crust on this side was a lot thinner, and there is lava or magma underneath that crust. And if a rock or something hit into this side of the moon, it would break into that thin crust, and lava would spill up out and cover big fields of it. So all these areas here are basalts. They're dried up lava.
Yeah. Now, we are pretty familiar with this. We might see it over the course of the year, each week, each night, maybe. But for me, this is a pretty like standard moon. And so as we
It's
kind of
boring.
explore some other moons, say that again.
I said it's boring.
Yeah, kind
No
of
offense,
boring.
Moon, but
But I always like to kind of draw comparisons to what we're seeing right now and what we might be seeing at other moons orbiting around other planets. But before we go to the next one, Marissa, I'm kind of curious because I've heard that the moon might be made out of cheese. Is that correct?
that is not correct. Sorry to burst your bubble there, Max. Nope, our moon is made out of rock. It's a nice big rocky moon. As I said, a lot of basalt here, a lot of dried up lava over on this side. Whoop, there we go. Let's zoom out a little bit more. There we go. And if we fly over to this side, there's still basalt there, but it's less obvious. We've got a lot more bumpy stuff. Now, as I said, this moon is kind of boring to me, and I kind of want to see a more interesting moon. Hey, Max, do you want to see a more exciting moon?
I would love to.
Excellent. I'm going to fly us to, let's see here. Let's go to this one, actually. So our moon, as we see as we fly away here, doesn't really have a whole lot going on it, right? It doesn't have any liquid water. It doesn't have an atmosphere. It's basically just a big rock with a lot of craters in it. This next moon we're flying to is very different. This next moon has oceans. It has clouds. It has rainfall. Max, do you know what moon I'm talking about?
Well, that sounds like stuff that we see on Earth, but Earth isn't a moon.
Earth is not a moon. We are flying to a moon of Saturn right now named Titan. Here we are right here. The picture of this is a little bit funky. That's because we've got snapshots, we've got images of this moon. Right around here, we didn't get images of this part of the moon over here and the parts down here. So that's why it looks a little bit funky. And this moon is named Titan. And if we look down right here, we can actually see those clouds on it. Now, I said there's clouds, there's rainfall, there's oceans, similar to Earth, as you said, Max, but these clouds and these rainfall and these oceans are a bit different in that none of them are water. It's all methane. Earth has a water system where water goes up into clouds, it rains down into the oceans. On Titan, there's a whole methane system, which is pretty amazing. The other really interesting thing is scientists aren't totally sure where all that methane comes from. They think maybe it's coming out of volcanoes on there, but we don't really know. Hey, Max, do you have any fun things about Titan you like to say?
Yeah, so you might notice this. It certainly does look a lot different than our own moon. Our own moon kind of looks like various shades of gray, whereas this side, it almost looks like kind of a fuzzy peach. And so because of a lot of that methane, a lot of those hydrocarbons in the atmosphere and on the surface, we almost are looking at a huge atmosphere of smog. And so because of that smog, because of those hydrocarbons in the atmosphere, it kind of produces this like orangish color that we look at, which is something pretty unique to the moon Titan compared to other moons we have already seen or we might come across later in the show.
Hey, Max, is this similar to the smog that you might see in like big cities and stuff?
It is. It's pretty similar, just like how that might change, slightly color the change of the sky. This is a much more extreme example of that. But just like how we kind of have heard of or might see smog on Earth, you really start to see it on Titan.
Really cool. Awesome. Hey, Max, do you have a moon that you want to visit?
So my favorite moon is a moon called Phobos, and it orbits around the planet Mars.
All right. Let's take a trip to Phobos.
Now, so far we have gone to 2 moons. We're on our way to 3rd. And just a reminder for everyone, if you do have any questions for us, or any comments or places you would like to see or visit, feel free to comment on the chat box in the YouTube link, and we'll try our best to kind of make that work into the show.
That's right. Also, if you're enjoying this show and you want to make sure you catch the next one, feel free to subscribe to the Pacific Science Center YouTube channel. That way you'll get an alert when the next time we get up here and start talking about stuff. Here we are flying past Mars.
Mm-hmm.
Now that is a funky looking moon.
It certainly is a funky looking moon. Now, for you, Marissa, does this look more like our moon or more like Titan?
You know, in the landscape, it looks more like our moon. In the shape, it doesn't really look like any of the moons we've seen so far.
Yeah. I like to call this one, and its name is Phobos, Phobos, kind of the lumpy potato moon.
That fits.
Yeah. Now, the crazy thing is moons normally are smaller than planets. Titan that we just visited is larger than the planet Mercury. But Phobos right here is only at its widest point, about 15 miles across.
Whoa, that's tiny.
That is very tiny, especially for even moons. And so that's why it kind of has this lumpy potato kind of structure or shape, because it doesn't have enough mass, it doesn't have enough gravity to completely form into a ball, into a sphere.
Wow. Now that's really interesting because I know last week we talked about the definition of a planet. We talked about Pluto, why Pluto is not currently on our list of planets. And one of the things that makes something a planet is that it needs to have enough mass to pull itself into a spherical shape. And the interesting thing about Phobos is that, and about moons in general, is that we don't really have a standard scientific definition of what a moon is right now. I'm going to zoom out a little bit as I talk about this. Right now, there's sort of more of an abstract definition, which is, a moon is a satellite. It orbits a planet or a dwarf planet. But there's no real rule about how big it has to be, as far as I know. It needs to be big enough to, not be a speck of dust. But as far as I know, there aren't even any plans right now to nail down a solid definition. And part of me wonders if that's because the last time we made a solid definition of something, which was a planet, there was a lot of backlash and a lot of folks with a lot of feelings about a certain dwarf planet by the name of Pluto. Something else that's interesting is that there's this idea that maybe some of these really big moons might have moons of their own. They might have their own little satellites. This hasn't been discovered yet, but that hasn't stopped the internet from naming them. From what I heard, the internet has decided those should be called moons, which cracks me up. Moons and moons. All right, awesome. Hey Max, are there any questions right now from our audience as we move on to the next one?
Posted yet.
All right, great. Then let's keep moving.
Something I like to point out is that right now we are we can see those 4 orbits that are closest to the sun. So the green, the yellow, the blue, and the red are the orbits of Mercury, Venus, Earth, and Mars. And of those 4 planets, there are just 3 moons. Earth has 1, and then Mars has 2, Phobos and Deimos. Now, of the 4 biggest planets, the 4 planets farthest out of Jupiter, Saturn, Uranus, and Neptune, those 4 have a collective total of over 200.
Wow.
Which is just nuts that half of the planets have almost 99% of the moons in the solar system.
Yeah. I guess Earth is pretty special in that it has a moon, and that has such a big one as well. I know you said Phobos is really small. Deimos is pretty small as well, right? Mars's other moon.
And I believe Phobos is bigger than Deimos.
Oh, wow. tiny, tiny moons.
Yeah.
And I believe the names Phobos and Deimos mean fear and terror, right? Which is kind of dramatic since
Yeah.
Mars is the god of war. All
Yeah.
right, sweet.
Now,
Let's head. Oh, go ahead.
I kind of mentioned that Phobos was one of my favorite moons. Marissa, what's one of your favorites?
One of my favorites. I will take you to my favorite moon. Let me find it. It was a little different from the one I was gonna go to, but this is a good one. Now, my favorite moon is one of Jupiter's moons. It is. I'll wait till we get to it. It is a little bit interesting looking. It looks a bit different from the other moons we've seen so far. Some folks have described it as like moldy cheese pizza. You'll see. You'll see when we get there. I love it so much. We're flying in on Jupiter's orbit, and we're going to zoom into the planet and then a little bit past it so we can reach one of its moons. And I say moons because, as Max was saying, all the really big planets have a lot more moons than the smaller ones. And Jupiter, I think the current count is 79 moons, which is a lot. Here we are. Here we are on my favorite moon. This moon is called Io, and as you look at it, you can see it looks kind of gross. The really, really cool thing about Io is if you notice all these dots, they all sort of look like black olives on the moldy pizza. Every one of these dots here is an active volcano. Io is the most volcanically active surface in the entire solar system, and it is constantly erupting. Some of these eruptions are more than a dozen miles high. It's amazing. And the reason this is happening is because right now I'm gonna zoom out a little bit here. Io is being yanked in two different directions. In one direction, it's being pulled by the gravity of Jupiter. In the other direction, it's being pulled on by some of Jupiter's other moons. And because it's being yanked like that, the entire planet bulges out in different directions. It's being stretched and squished. And all that pressure keeps the inside of it liquid. It keeps it really, really hot and liquid. And all that liquid on the inside needs to go somewhere. So it's popping out in all these different volcanoes. Super, super cool. The other cool thing about one of the other cool things, there are many. If you notice the color of it, it has that sort of weird yellowish, kind of gross looking color. Scientists are pretty sure that is sulfur. So the whole planet is covered in sulfur, which would mean it smells kind of like rotten eggs. So this is my favorite moon because it is stinky and covered in volcanoes. One other cool thing I wanted to mention about Io. I know last week there were a lot of questions about lightning on other planets and whether Jupiter has lightning, and the two of us weren't totally sure. I think we ended up Googling that. But I ended up looking that up in this past week because I was curious about it. And yes, Jupiter has lightning, and its lightning actually comes from Io. So as Io goes around Jupiter, it what is it does? It crosses its magnetic sphere or something. I believe that's what it was. And doing that generates electricity. It's magnetic lines. That's what it was. It crosses across its magnetic lines, and that generates electricity. And basically, Io just gets covered in about 400,000 volts of electricity, and then those travel along the easiest route, which is right down towards Jupiter, creating a whole bunch of lightning up in Jupiter's upper atmosphere. Io. Io is just the coolest.
Yeah,
Did I call it Titan earlier?
Io is nuts. The couple things I like to point out is, as you mentioned, Ios kind of get pulling and pushed in all directions. So I always like to think that the kind of the rocks, the surface, almost kind of warms up more like silly putty. So it kind of gets a little bit more elastic, a little bit more stretching, making it easier for those volcanoes to kind of pop up with the eruptions. Now, Marissa, we are familiar with some lunar eclipses, solar eclipses here on Earth, and it looks like I might be able to see one from Io on Jupiter, that little black dot.
Right there. Yeah, so that's just the shadow of the moon, right? The sun is shining on this half of the moon, and that creates a shadow right down there. Very cool. Thanks for pointing that out. I didn't notice it.
Yeah.
All right,
Now
nifty.
I always like to show that because that shows how much smaller some moons are compared to planets. So even though they are smaller, um, they have differences just like planets, and just like planets, moons do have gravity, although the gravity of a moon is going to be quite a bit different than the gravity of a planet.
Certainly, yeah.
Now,
All
Marissa,
right.
we do
Yep.
have a question about another pretty popular moon of Jupiter, the moon
Ah,
known as Europa.
Europa. Let's fly there. What was the question?
Just some interest in seeing if we could visit it quick.
Of course we can. That's what we're here for. Let's go. So we're noticing Europa is a little bit further away here. We're getting a nice look at Jupiter's rings, though, as we fly by. That's kind of cool. Here we are.
No, I
Now,
think I see.
Europa. Yeah, I always think of Europa as kind of the opposite of Io. Io is this really, really hot moon covered in volcanoes. As you fly in Europa, it looks pretty different. Hey, Max, what is Europa covered in?
It is covered in ice, and so
Mm-hmm.
you might be able to see, like, it almost looks like cracks, kind of scratches on the surface. Um, and those are cracks from some of the gravitational pulls of the moons and especially of Jupiter that we noticed in a different way on Io.
Here, I'm going to zoom us in on this nice crater right here. We can see this crater with all these cracks coming out of it. The other cool thing about Europa is that scientists are pretty sure there is a liquid ocean underneath all of that ice. Um, and if that is the case, Europa is one of those places that could potentially hold life in our solar system. I think we're planning to do another show at some point, really delving into these moons and really delving into where there might be life. But scientists are finding the more we look at these moons that it's far more likely we'll find life on a moon rather than another planet, in our solar system at least.
Mm-hmm.
I'm just going to fly us up on top here. We can see a few more cracks.
Yeah, and it's still been a mystery because our oceans aren't covered in a full layer of ice. And so what we've been able to piece together definitely isn't as ideal as we might expect as far as the amount of information we would like to have. But
Mm-hmm.
scientists are trying to piece together what information they have to make these predictions as far as if Europa would be able to sustain life or even be able to have life completely independent of the life here on Earth.
Absolutely. All right, sweet. Let's keep moving. Max, did you have another moon you wanted to visit? I have one in mind if you don't.
If you've got one in mind, go ahead and let's go to that one next.
All right, excellent. Let's fly there. This is a moon of Saturn we're going to, another moon of Saturn. Titan was a moon of Saturn as well. This one is called Iapetus, and it is a super weird one. I'm a big fan of the weird moons, so those are the ones I'm going to fly us to. Now, Iapetus is weird because of how it looks, and I'll show you once we get there. We're gonna fly in on Saturn here. That yellow line is its orbit. And we're gonna zoom a little bit past. Here we are. Iapetus. So the weird thing about Iapetus is the way the colors on it. So this side of the moon is really, really white, bright white. But the other side of the moon, the other half of the moon, is dark. It's this really dark color. It's got this weird two-color thing going on each side, and this is a sort of a mystery. This is another thing scientists aren't totally sure why it looks like this. There's a few different ideas. There's another moon of Saturn's called Phoebe that flies by that's really dark colored. So there's an idea that maybe some of the dust and stuff from Phoebe falls off and sticks to Iapetus. One of the ideas is that it has something called, and I had to write this down because it's a very technical sounding word. Let's see. Thermal segregation. That's a lot. That's just a fancy way of saying that one side is warm and the other side is colder. So they think maybe Phoebe flew by, something flew by, and it got this side a little bit darker. Now, darker stuff absorb more heat. You might have noticed that if you go outside in a black t-shirt, you get hotter a lot faster. While lighter stuff reflects heat. If you go outside in a white t-shirt in the summer, you get hot. It takes longer for you to get warm. So they think that this side got really, really hot. And that meant any ice on that side, and they do think that this white stuff over here is ice. Any ice on that side would have evaporated, and that would have traveled over to the colder side over here. And over time, there's thermal segregation. The hot side and the cold side meant that all the ice went over here, and it stayed away from over here, and that caused this sort of weird color thing going on. The other thing I want to point out about Iapetus is this line right here. It's kind of hard to see. Max, can you see that right there?
I can. Very kind of, is that where a couple of the almost white polka dots kind of lead into the black area?
Yeah, sort of this right here. It's kind of hard to see in this program, but this is a chain of mountains that are about 6 miles tall, right along the middle of the planet here, right along the equator. Let's see if I tilt this. Whoop, too close. If I tilt this way, maybe it's a bit. Not quite. That's fine. This is another sort of mystery on Iapetus is why is there this long line of really, really tall mountains that are way taller than everything else around here? And from what I've read, there's an idea that maybe used to be a ring system that collapsed on it, or maybe it was something to do with if the planet spun faster when it was a lot younger, that could have forced parts of it into these big peaks. We don't really know. This is a mysterious moon.
Yeah, that's very interesting. And I'm going to kind of build off of something you mentioned. So you mentioned how the white sides or white color is often reflecting more light. So I always think of that like if it snows and then it's a sunny day, you might walk outside and it's super bright, like it almost hurts your eyes. And so that thing of reflecting sunlight, something that we call albedo. And so it looks like half of this moon has very high albedo, it reflects very well. The other half does not. It absorbs sunlight really well. And this just popped into my head. I'm not sure if you know this, Marissa. Do you know, does that affect the how much does that affect the temperature?
It would affect the temperature, and I don't have the exact numbers, but the dark side I know is significantly warmer, I believe, than the light side on it. Which is why ice just doesn't go over to the side. It would instantly evaporate. There was one other thing I wanted to point out. I noticed as I was flying over this way. There's a really impressive crater right here. We can see about 2/3 of it. I just wanted to point that out.
Yeah.
That would have been a pretty big impact. All right, nifty. We still have about 10 minutes. Max, do you have another moon you want to visit?
Yeah, we talked a little bit about like icy moons reflecting back. So one moon that is pretty good at that is the largest moon of the planet Neptune. And
Let's
so
fly there.
I always think that makes sense for the name because Neptune was the Roman god of the sea. The Greek equivalent was Poseidon. And so they named the largest moon Triton. So almost like kind of what Neptune or Poseidon would kind of carry, kind of what looked like a big fork. Now, being this far out is already super duper cold. much colder than anything we would experience on Earth. But as we'll be able to see as we zoom into Triton, it is super reflective. So it reflects a lot of that sunlight back, making it even colder than something else that wouldn't. Now, Marissa, do you know, I'm blanking, do you know the temperature of Triton?
I read it's about negative 391 degrees Fahrenheit. So super duper cold.
Yeah, that's super cold. And it looks like we do have a question. This might be referring to the Iapetus. Does the weight of the ice affect the moon's rotation?
Oh, I'm not sure. I know that they're thinking Iapetus is a very it's not a very dense moon, so they're actually thinking that about 2/3, I want to say, of the moon is ice. Most of the moon they think is ice. So I guess yes would be part of right because it would make the moon bigger, which would affect its gravity and how it moves and everything. Um, but I don't think it's that it's uneven, like one side is heavier than the other. I do know Iapetus is another one that is tidally locked to its planet, though the same side always faces in and the same side always faces out, which I believe is fairly common with moons. I think most moons, correct me if I'm wrong here, Max, but I think most moons are tidally locked. And the reason that happens is because they're a lot smaller and they usually start out rotating, but the pull of the planet's gravity slows that rotation down until they're just sort of stuck.
Yep, and especially with some of these not biggest, but bigger planets we've been able to visit, the gravitational pull is just so much stronger from the planets like Jupiter, Saturn, even here like Neptune, compared to what these moons are experiencing from the mass they have.
Absolutely. Good question. Thank you. Cool. Anything else you want to say about Triton?
Yeah, Triton is a very odd moon. I think the weirdest thing about it is Neptune, if I'm remembering correctly, has 14 moons. Triton is just one of them, but if you put all the mass of those moons together, Triton has like 99% of it. So it is significantly larger than any of the other Neptune moons, but it orbits the opposite way than what we would expect. So an idea that some scientists have kind of put together is that Neptune kind of pulled it in from an area known as the Kuiper Belt, which is where Pluto is. And instead of being some random asteroid, and here we have some more Kuiper Belt objects, those blue dots. So instead of being just another random object or asteroid, or maybe even to some extent, maybe a type of planet, it got kind of swept up into Neptune's gravity and orbiting around Neptune primarily rather than the sun, and it became a very unique moon of Neptune.
Very cool. So when you say it orbits opposite from how we expect, what do you mean by that?
Yeah, so that when it orbits opposite, so that is referring to something called retrograde. And so almost everything we observe orbit in the same direction. Now I'm trying to remember. I'm getting it mixed up now. And so whether it's, I think it's, is it clockwise is everything?
Oh man, I don't remember either.
Well, regardless of which one it is, if everything we expect to go around and orbit clockwise, Triton is doing it the opposite way. So it's going counterclockwise, and maybe it's the opposite. Maybe it's going clockwise where everything else is going counterclockwise.
but Neptune's still going the same way, right? It's still going the same way as everything else.
I believe so, yes.
Cool. So Neptune's doing its thing and Triton's off going the other way. This is my very scientific motioning here. Um, all right, fantastic. We only have about 4 minutes left. Are there any last questions folks wanted answered in this time? I think 4 minutes is probably good for answering questions. I'm going to zoom us back out as we do that.
Now, something I often like to share is that we have kind of touched on some of the more famous moons, the more noticeable moons within our own solar system. But that doesn't mean that these are the only moons in our solar system. Within the last couple of years, we've discovered 10 new moons orbiting around the planet Jupiter to bring that total up to 79. And then I think it was within the last year, we just discovered 20 new moons orbiting around Saturn to bring that total to 82.
Yeah, Saturn's currently in the lead with the most moons.
And do you think Saturn will always be in the lead, or do you think that's going to change as well?
I suspect that'll change. Jupiter is just so big. It is far and away our biggest planet, so I think it is likely to capture a lot more moons than Saturn. But that's just my guess. Who knows?
Marissa, I just saw a question. We kind of touched on how moons can be really different. So our moon is kind of gray and cratered. Titan has a thick atmosphere. Io has a lot of volcanoes. Why are the moons so different?
That is a great question. Feel free to jump in here, Max. I mean, I think a lot of it is just the difference in where they're at and what they were made of. I think moons are made mostly two different ways. Either they're captured, they're flying by and the gravity of a big planet grabs them and captures them, or they're formed out of the leftovers of that planet for when that planet formed. So the composition of the moon, I think, contributes to it, just whatever it was made out of. Where it is, I think, is part of it as well. If you think about Io, which is so close to Jupiter that it's being pulled on and squished and pulled, and that makes it different from something like I don't know, like Iapetus, which is further out, from Saturn. Yeah, that's my best answer. What have you got, Max?
I would say, yeah, I agree with everything you said. I think one indicator is kind of where they are as well. There aren't many moons close to the sun, and a lot of the moons we see farther out, and so that formation is just different than what it was probably farther out, where just by chance it was in the solar system, and then kind of how that formation was impacted by some of the planets or even other moons close to it.
For sure, yeah. Awesome. Good question. It is 1:40, I believe. We are pretty much out of time. So I just want to thank you all so much for joining us or for watching this later on if you do. I think the plan is to do these shows every Wednesday at 1 p.m. So tune in next week for more. Yeah, thank you so much.
Yep, we hope to see you soon.
Bye.